Hello everybody, today we are going to be talking about acids and bases, which is the third booklet in our chemistry unit and the final booklet. So we're going to be classifying some acids and bases, looking at the pH scale. We're going to explain how they neutralize each other. This is a term we're going to be using a lot. We're going to write some balanced chemical equations. We're going to discuss how this is a double displacement reaction. We're going to look at some applications of acids and bases. And then we're going to talk about things like acid rain, and then nitrogen oxide, sulfur oxide emissions, and also the effects of acid rain on lakes. So let's get into it. So acids are sour tasting, water-soluble substances that are found in many common products. They are so reactive that they can combine with many other substances. For example, acids can react with metals to produce hydrogen gas. So for example, if we take HCl, which is hydrochloric acid, the same acid that's in your body, and react that with something like magnesium, which is a metal, it will react very aggressively and produce magnesium chloride, which is a salt, and it'll produce hydrogen gas. And so that's done by having two of these hydrochloric acid molecules react with the magnesium. The reason for this property is really about hydrogen. So hydrogen is our smallest and most reactive element on our periodic table, really. It is very, very tiny, and it can move around and get in and react with many different types of compounds. Remember that on our periodic table, at one point we sort of alluded to the idea that you can put hydrogen over here, or it could also fit over on the other side right next to helium, because they kind of have similar properties. And that sort of mobility of hydrogen means that it can react with almost everything on the periodic table. There are very few elements that don't have some sort of chemical reaction with hydrogen. Now, acids need to be used with care, as they are usually very corrosive. And so corrosive means that it will react with the skin, can cause burns on skin organic tissues. So when being exposed to an acid is very dangerous for your skin, and you can actually get a very, very dangerous burn, but they are also good conductors of electricity, which means that they pass electricity. A good conductor is a material that passes electrical current freely. So if you want electrical current to run, you need acid. And you'll notice that if you're familiar with car batteries, often we talk about car batteries as lead acid batteries. And that's because they have an acid in them as well as some lead. And that's one of the ways that we used to make very old batteries, or there's some of those lead acid batteries are still around. They're very effective acids. Very effective batteries, but the acid inside makes them very dangerous because of the corrosion. Almost all acids contain hydrogen atoms. When an acid dissolves, it releases the hydrogen atoms into the water. Well, you know what? I do want to mention one thing. Corrosive will cause burns on your skin, but it also means that corrosive also means that the acids will break down metals, or most metals. So especially pure metals like iron, and a couple of the other ones, copper and things like that, those can be reactive to acids. And we have to be very careful. If we think that that our material is going to be close to an acid, then we have to think about what kind of container we use. We shouldn't use a nickel or an iron container to hold acid in it. And instead, we should use something like a plastic or aluminum, which is resistant to corrosion. When an acid dissolves, it releases hydrogen atoms, hydrogen ions. So what we're talking about here is something like hydrochloric acid. When it is reacted with water, it will release its hydrogen into the water and split up. Now this reaction is actually, this statement, I think we're going to take some care here. This is actually a misunderstanding. Or an approximation. So what actually, the better way to write this, and something you might come across if you have to do this in university classes, is that what actually happens is that the hydrogen is released, but it's not released to be free and floating by itself. Instead, it reacts with water to become something called hydronium. And the chlorine ion is released. Now you can see that the math here is kind of the same. We ended up with a positive charge and we ended up with a negative charge. So it doesn't matter too much if you call it hydrogen ions or if you say that it's hydronium ions. But if you ever want to think about what's actually happening at the water, like if you could get down and shrink down to the size, you wouldn't be able to find these by themselves. They're not really out there by themselves. They are always paired up with a water molecule. And this hydronium is something that we do have in nature and something we can find and we can isolate. But we can't actually isolate this. We can't find the hydrogen ions by themselves in water. Acids can do environmental damage, as we will discuss further. As well, acids are very important to industry. The most important industrial chemical in North America is sulfuric acid. It reacts with thousands of other chemicals and is used as a starting material or a catalyst in many reactions. Catalysts are substances that can help a reaction happen without being used up themselves. Sulfuric acid is used to make fertilizers and explosives and to refine oil and to electroplate metals. So here are some examples of some common acids: hydrochloric acid, vinegar, citric acid, ascorbic acid, lactic acid, carbonic acid, cetacillic acid, sulfuric acid, and nitric acid, as well as hydrofluoric acid. And notice that the formulas are very interesting. They have the formulas are all different. Some of them are pretty straightforward, but other ones are a little bit more, a little bit new to you maybe. So you might have to sort of review them or memorize them is a good way to go about it. One of the things you might have to do if you're having trouble remembering the names of all of these acids. So certainly, suggest that maybe you practice writing them out. You can use cards to write it on one side and then flip it, or write it, and so like a recipe card. Put your hydrochloric acid on one side, HCl on the other. But I'll try to point out some helpful tips here as we talk about them. And sometimes it helps to remember where they come from. So hydrochloric acid is in our stomach, so that's a type of stomach acid, or it is stomach acid. It's pretty commonplace. We use it to break down food. It kills germs in your stomach, so very important. Vinegar is of course used in pickling. So if you ever have pickled fish or pickled eggs or pickled whatever, then it's because of vinegar that's been in there. It's also can be a product of fermentation. So it's a product of fermentation. So if you have an old wine, and if you have a wine that you were making and you put the wrong type of yeast in there, or wrong type of bacteria, then you can actually get it. It'll start to produce vinegar, and you'll get kind of a wine vinegar. Doesn't taste nearly as good. Now, citric acid is found in the citrus fruits. citrus fruits. So that's your oranges and your all sorts of other things. Oranges and probably even mangoes and things like that have all have citrus fruit in it, all have citric acid. You also see that in like sour candies, like Sour Patch Kids and stuff. You can even buy, sometimes you can buy the citric acid rocks at the store if you're doing some baking. Ascorbic acid is a product in, ascorbic acid is vitamin C, right, of course. Vitamin C. So it's incredibly important for your immune system. And that's one of the tricks about this, is that you might not even realize that something is an acid, even though it's like sort of a ubiquitous thing like vitamin C. Lactic acid is in your milk, particularly sour milk has lactic acid. Your muscles can also make lactic acid as well. So your muscles will produce lactic acid if you are overworking them, particularly if you're not breathing enough or you're working too hard for too long. And then also we get it in milk, sour milk particularly. So when milk breaks down, the lactic acid can become more potent, more concentrated, and that's when we start to see the that sour taste to it. Carbonic acid is in like carbonated drinks. Carbonated drinks. So Coke and Pepsi, all those sorts of things. You can also find in the ocean. Ocean acidification is due to carbonic acid. So it is also pollution. Pollution creates this in the ocean. Now, salicylic acid, this is a type of aspirin, or this is what aspirin's real name is. It's a type of blood thinner. It's been used for eons. It's also able to extract it from, I believe, from birch bark. Is that right? Or is it willow trees? Sulfuric acid is in batteries. That when I mentioned earlier, the idea of the lead acid batteries, the acid there in lead acid batteries is in sulfuric acid, and it's also in fertilizers. Nitric acid is a pollutant. This is in pollution, and it's also in fertilizers as well. So we do use a lot of acids to change the pH of the soil, and then hydrofluoric acid is used in industry. It's industrial uses, and it's incredibly dangerous. Very dangerous. All right, so I think that covers us for acids. So let's take a break, and we'll come back in our next video to talk about bases. But I would like you to look around your own house and see if you can find some examples of acids that are around you right now. All right, we'll talk to you next time.